This conference will now be recorded.
All right. So today, as for the agenda, right? Let me put my notepad. Let me share my screen. Hope my screen is visible to you guys, right?
Yes.
It's visible. Okay. So as per the plan, right? So and the course streamline whatever things. So first we'll discuss the database, right? Database in the form of the SQL Server as per the plan. So any database you can take it, but if you don't have a SQL Server, that's just fine because you can along with practice with other database also. Because once you learn one database, it will be quite clear to get into the other database. There is nothing changes and all. Okay. Second, once we finish up this SQL Server, second we'll start with the Power BI. This is the sequence. Third, uh, what else we are discussing? Power BI, database, then the ADF. Then fourth, it will be little bit Excel. Just the fundamentals we'll see here. Excel, how to work on this one. So these are the four areas of the courses which we will discuss in this part. Okay. So the first one we'll discuss about the database right today. Let's do that. So just I want little bit interaction for you guys, like how much you know about any kind of database or where you are right now, like any kind of beginner level, advanced level, or something you know, or you don't know anything. That's fine. Let's just I want to know that from everybody, like where you are exactly in terms of the database. Please go ahead. Hello. Yes, please.
Hi. I'm like I know what is the like a table, how the tables are created and all.
Mm-hmm.
Um, like joins and I mean in depth I don't know the basic things like creating tables,
Okay.
update and all these things I know. I'm aware of that.
Okay. All right. And
Yeah,
what about
same,
others?
same with me actually. The basic SQL thing.
Right. What about you, Bali, Alice, Nagesh?
Yeah, I know the basics of SQL, right? Writing queries.
Mm-hmm. Okay. What about others? The two persons, Alice and Nargis.
Hello.
Mm-hmm.
I know a little bit, but I made it a table and database about 5 or 6 years ago, but I forget right now.
All.
I
Okay,
should
no problem.
try. Yeah.
Okay. So I got a basic idea. Please go and mute, Nagis.
Okay.
So as far as what I understood is that okay, yeah, everybody knows little bit of basics, okay, but they don't either they're not in touch or here and there, right? So let's start with the basics only, then we will go to the deep, right? So that's way so that we can learn and refresh it also. If somebody not in touch with the SQL also, they will start looking into that, right? So let's see that. Now, very first question I want to ask you guys, what do you mean by a database? This is very basic class today, okay? It's not like I'm doing anything here. What is database for you? What exactly a database? Okay, please go ahead.
The collection of data is called database in SQL thing.
Okay, let me write it. Different things. Collections of data. Okay. Anybody else? What exactly?
That is the place where we can store data and retrieve data,
Store data.
store
Or you
or
can say
update.
a container, I can say, right?
Yeah, yeah, yeah.
just like a container. Okay, fine. Anything else? Okay. So basically, this is well-defined definition of this. Let me just simplify this. So it is database. What is a container, right? Is a container. Container means we can store and retrieve, right? Retrieve the data of related data. What is meant by related data here? So let's take, suppose you have an Excel file. Mhm. So the Excel file name is, let's take order.xlx, this one. The name is suggesting that it is an order file. And in that Excel file, I am keeping all the inventory information, like what is my expenditure, what is my budget, all these things, right? It doesn't make any sense. Suppose if I given this file to somebody else, so when he is trying to open that file, he is expecting that order.xlx file should have information about the orders or related to the sales. So that is the related data. So wherever you are defining any kind of database, so that inside that what content should be, it should be related. It's not like random, we can put it everything. So one database is there for the sales, one is for the HR, one for the finance, one for the others, right? So we can't mix all these things. Yes, we can mix it if there is a requirement, or that should be also some kind of relationship of the data. So that is very important. Like what you are storing inside the container, that is a related data. Okay, make sense? Any questions?
No.
Okay, all right. Now, how you will store the data inside the database? Data in the database, always data stored in the form of a table. Okay, so what is table? Table is just in the simple rows and columns. Okay, in the form of a rows and columns. Whereas the rows represents the header and the rest of the things data and rest is data. First row, sorry, not the rows, first row. First row represent header and rest is the data, right? So this is the way you will store the data inside your table. Okay. Now, before storing anything inside the table, we need to understand certain principle in the database. Okay. So there are two principles in the database to store the data. Okay. Let me put it in this way. The principle will be, first principle is the normalization. Okay. Second is the denormalization. Okay. So the first principle is the normalization and second one is the denormalization. So let's go through this process. What is normalization? What is denormalization? All these things. So I have prepared one PPT for this, the normalization. Let's go through that. Okay. Let me open that normalization and start. Let's see. So here the normalization is, it is written, right? It's a database technique that organize table in such a manner that will reduce the redundancy and dependency of the data. Okay, what do you mean by redundancy here? What do you mean by redundancy? Anybody have an idea what is redundancy?
Repetition,
Right, so
like
redundancy is
duplicate.
something,
Yeah.
right? So duplicates, all these things, that is called the redundancy and dependency. So data will be dependent on each other, but not more than dependent. Okay, and this technique is used to avoid the insertion, updation, and deletion anomaly. We'll come to that. What is anomaly? Now, the third part is the normalizations divides larger table into smaller sets of table and rather than using the relationship. So this all 3 points we'll discuss in detail one by one by one. Okay. Any questions as of now? By seeing this the first slide, let me, if not, I'll go to the next slide.
Can you please explain it again?
What switch point?
This part that you a
Okay.
table, a big table to small tables.
Okay, we'll come to that. In a sense,
Yeah.
let's take let's don't talk about a table. Let's take in an Excel file. You are very familiar with Excel file, right? Everybody. So in an Excel file, let's take I'm talking about a company. Okay, in a company, I have so much information, right? I have employee information, right? I have my my sales information. I have my finance information. I have my HR. Suppose I'm recruiting some members. I have that information. Suppose think like in a single file, I am keeping all the information, everything, each and everything. I'm just dropping and just doing a dump. Okay. So is it advisable if somebody open that Excel file and it contains around, let's take 60 to 80 columns of data, right? And suppose you want to get the information, say that what is the total employees in my company? What is the total employee? So it is very hard to get it from the 68 columns to fetch that how many employees in my company. So if that kind of larger things are coming up, right? Let's split it. So one part will be employee, one part will be their information, one part will be the sales, one part will be the this one. So we'll just split the data across small chunks in the form of a file or in the form of a table. So that's the last point it is saying that normalization divides the large tables into smaller sets of table and make it a relationship between these two. All right, make sense? Did I answer the question? Hello. Okay. So now this technique we'll discuss about the next topic here. What is anomaly? Anomaly here is this. I just give an example here. What is anomaly? Something that is, sorry guys, can you just keep yourself mute? Yeah. Sorry for that. So anomaly means something that is not according to the standard or normal. That is clear cut definition of an anomaly. Something that is not according to standard and normal. Now take an example of the below table here. Okay. So there are 4 columns are there. One is ID, name, address, and their department. Okay. So I have around 4 employees here, 3 employees. So if you take the example of 1001 employee, he is part of both sales and finance. Okay. Now this guy 1002 is Vicky and all this these guys are there. Okay. So here the problem is so many problems are there here. First of all, the same ID can't be provided the same different names, right? 1001 is Ravi and 1001 is Suraj also. It is never possible. It is not possible. This is a wrong data, right? Third, this also the same problem. 1003 is one guy, 103 another guy. How it is possible? There is no uniqueness is coming on this is in this data. So That's what the anomaly is. There something is that is not according to the standard or normal. Okay. Now, take an example of another thing, another department. Just think like, suppose you joined a company, hmm, and on the first day, you are not sure that on which department you will get it or you will get into it. Okay, whether you will be part of a sales team, whether you are part of a finance team, or you should be part of a IT team or any else team. Because on the first day, it is not decided. And suppose this is an entry, you want to keep it, insert. Okay. So I'm keeping 1004 in your name, XYZ, in your location, whatever may be. And this column, I want to make it as of now, I don't want to enter anything department, right? Because it should be null. In this case, I don't have any rule also, like whether the department can be a null, I can't skip it, or department should be null. If it is something the new employee, I should put it as null. That rule also, it is not set. The first problem in this data is the uniqueness, right? Second is that on the department, I don't have anything. I don't have a rule. Rather, I can say I then put it a blank. Fourth point or the third point, I can say update. Let's take somehow I want to update 1001 employee to IT. Suppose what happen is one employee is there, he's working for one X department and he wants to switch into the Y department. Let's take in the financial year, he got promoted and he wants to switch into the another department. Now, in this case, 1001, first of all, there is no uniqueness. Second, these two guys want to update into IT. So if I update based on this 1001, then these two guys will be changed to IT, right? This will be IT, this will be IT. But the problem is I don't have uniqueness here again. Which employee, which employee I will go for the IT, right? And I can't take the name as a unique also because name can be repeated. One guy will be Ravi, another can be the Ravi also, right? I can't do update based on that. So I have so many problems here in this table, which is not according to the standard or the normal. Okay. And suppose another problem I have, suppose 100 an employee leave the company. Hmm? So I want to just delete the record from that, right? From my table. So in this case, if I remove the 1001, both the records will be. So that is one more problem. So I have first problem I have is the data is not unique. There is no uniqueness. Second, while inserting the data into the table, there is no defined rules rather. I can say I don't have any rules like whether it will be a null, not null, whatever may. Second, I can't update the record based on any unique ID. Right? It is if it's trying to update the records, it is updating the records for everything. Right? Third, the last point is suppose an employee is moving out of this. If I want to delete the records, it is deleting everybody here. So this is an example of a anomaly. This is called the anomaly only. And if you get this kind of junk data, right? So the process, how you can define the process to simplify so that the data would be good, okay? There will be some uniqueness and insert, delete, update to the table will be on smooth side. That process is called your normalization, okay? Any questions? I'm just stopping here. I'm going very slow today, okay? Just anybody have any questions here? I'll answer that. No questions? Good?
I have question, sir.
Mhm.
We have to make an ID for each person.
Right. Yes, you need to do that. So that's what that is the ID. We need to create it. So this is a
We
chunk. Yeah. So the I'm just showing you that this is a chunk data. and you need to give a uniqueness to the data. Yeah, that's correct. That's correct. Okay. Anything else?
But I didn't understand exactly that how there is 1001, but another
Mm-hmm.
1001, 21001.
Mm-hmm. No,
So,
I'm just don't go the data. This is an example of an anomaly. What is anomaly? I'm trying to say. That's why I kept this table. You will not get this kind of data in real time. I'm
okay,
just supposed to give an example that what is an anomaly and what is the
okay,
problem if you have an anomaly on the table. Okay,
okay.
make sense?
Yeah.
Yeah. Any other questions? All right. So now to avoid this and the normalization principle, let's go little back. How to go to back? Yeah. So here the first I slide I saw that right. The normalization is a database technique that organize table. Okay, organize table. Second is to avoid the anomaly. I discussed the anomaly here. What is anomaly here? And the third part is normalization divide the large tables into smaller sets of tables. So these 2 points we will discuss now. The first point we will discuss what is anomaly. Okay, this is anomaly. Make sense? Now next go to the. So there are uh, how I can different normalization process we have. So there is a first normal form, second normal form, third normal form, and fourth normal form. Okay. So basically, in a real-time data, we just go little bit till the fourth normal form only. Beyond that, we have fifth, sixth, seven also, but never I saw in my real time that the normalization will go in that way. Okay. So take an example of what is called a first normal form, and if this kind of data is there, how to make it into a first normal form. Okay, let's take an example here. So the first rule of the first normal form is an attribute. Attribute is represented as a column here. The table cannot hold multiple values. Okay. Third point, second point, I'll go through that. It should be hold an atomic for a single unit values. Each record needs to be unique. Now, take an example of this table. Okay. Here, are you finding any kind of uniqueness? Yes, there is an uniqueness is there because each employee ID is different here. But the problem is this information. So there is a junk information here. There are multiple information separated by a comma. In case of mobile number, this guy is having two mobile number. So this is first mobile number, comma, second mobile number. This is not advisable. It is saying that an attribute or a column of a table cannot hold multiple values. It should be single. Mobile number means mobile number only, or a department means department. It can't be like suppose he is part of two department. I can't put it in a single column. Sales, comma, purchase, or purchase, comma, IT. I can't put it like that. So in a single column, it should not hold multiple values. Okay, I'm going. Just let me know. The pace is very fast, or it's okay. I want to just little bit slow. Okay. So if this is a data and this is the problem we are facing, how to avoid this? Suppose let's say you are a database architecture, and suppose somebody has given this data to you. So how will simplify this table? Take an example here. So this is the example of this. Okay, so this is my the previous table. Okay, then what I'll do, I'll just simplify each and every table. See, now e0, let's take the Smith is having two mobile number, so I'm keeping two records for this. So E1102 Smith first phone number, E110 Smith second phone number. Okay, so like that So for the Kim also, I just giving a 2 phone number here. So this data is a chunk, and this is called the first normalization form of a table. Okay, any questions? Guys, you're so silent. What is the issue?
I'm good.
Yeah,
Okay,
me
I
too. I'm
got it.
also good. Yeah, got it. Yeah, it's clear.
I got it.
it's clear. Okay. Now let's go to the second normal form. This is your second normal form of a table. This is a final table. I'm not doing anything on this one. Okay. Here, the rule is the second normal form definition is that first of all, whatever rule you are specifying in the first normal form, it should continue here. It should be in the first normal form. Second, the all just read this statement. All non-key attributes are fully functional dependents on the primary key. We'll discuss about the primary key. Primary key is something like a column of a table which holds unique records. Okay. Now, in this case, if you see this, the problem is I have an employee ID, okay, then I have a qualification, then I have a age. Okay. So here one employee can hold multiple qualifications, right? Like he can be a MA, he can be a BTech, he can be a MTech, or it's a computer science, anything. Multiple qualification somebody can have, right? Here, in this case, I can't put the uniqueness of an employee based on the employee ID. It's not possible. So I need to hold two columns at a time. First column will be my employee ID. Second column would be my qualification. So that if I combine these two, this mentioning, right? This is called your composite key. So employee ID plus qualification. That makes a uniqueness here, right? 111 qualification, 111 qualification. So if you combine these two columns, then it is specifying a uniqueness to the table. And the last column, which is called the age, which is nothing but a non-key attribute. So here see that all non-key attributes are fully functional dependent on the primary key. So it means that this age column, if I take it separately, or say that age 38, doesn't make any sense to me unless until this 38 is combined with employee ID and qualification. Then only this 38 is making sense to me. They can, okay, yeah, this employee ID 111, which is having a qualification of a BTech or MTech, his age is 38. So the last column, which is there on the non-key attribute, is fully dependent upon the employee ID and your qualification. So this is called a second normal form of the table. All right, make sense? Any questions here? We are good?
Yes, yeah.
Okay.
I have a
Okay.
question here.
Please go ahead.
The employee ID 111 has the composite key, like employee ID plus qualification is 111 plus MA. That
Right.
age is 38. That is the non-key attribute. So
Correct.
again the non-key attribute 38 in the second row is
Hmm.
also having that 111 plus qualification is different here. BTech, there is no
Right.
unique, right?
No, no. If you take this as a unique, right? So let's take 111 MA 38, 111 BTech and 38. These two records are unique, right? As per
Both
the,
refers to a same person or a different person.
it's the same person only, but with a different qualification. Let's take let's take Samir is an employee, is having two qualification. One is BTech and MTech, right? So
Mhm.
both the qualification is maintaining in a different in a two records. I understand what you are trying to achieve. So this is a second normal form. I not even go to the third and fourth. So this is now this is see. This is the way we started. We are putting two column each for each and every. Now we are defining each record with a composite. Okay.
Mhm.
Then further we need to simplify this. It is not the last one. I got your point. What exactly you were trying to say.
Okay.
Okay. Yeah.
Okay.
Yeah. Okay. Now let's go to the third now. Here, just see that data. First of all, the in the third normal form, yeah. So the first of all, it should be on the second normal form. So it parcelates to the first. So in the third normal form, everybody should be on the first normal form, in the second normal form. Then what is the changes on the third normal form? So just see that. The first rule is there is no transitive functional dependency and transitive functional when changing all these things. So this is definition. Let's not go to definition. Take an example here. So here, what exactly you are trying to say just before you ask me on question here, right? Now this is simplified here. See, employee ID is a unique now. The E110, E101 is a unique, right? Is a primary key. So that's what I told you that in the second normal form, this is not the final one. We'll morely simplify this process. Okay. So this is the simplification here. The employee ID is a unique column. So each employee ID is a unique. But here the problem is what? Let's take I have a zip code for the each and every this one, and I have the city for that guy. Okay. So here if I take the employee ID, the zip, and the city, these three columns, employee ID, zip, and the city. City is depending upon the zip, right? So whatever the city will be there, for that the zip code will be there, I need to put it. Okay. And that is dependent upon the employee ID, correct? So employee ID should be part of a city, which city belongs to. And for that one, I need to put the zip. Okay. Again, I would say city is indirectly depending upon the employees also, right? So in this case, how the dependency is working, the employee ID, the zip and the city, one dependency, and city is indirectly depending upon the employees also. So let's take, I want to say that how many employees are from Chicago. So this city is belongs to the employees also, right? Because what are the number of employees I have in the Chicago city, right? So this kind of relationship here is a very problematic here. So because these two are dependency, okay, and changing of a zip and changing of a city, right, is affecting my employee information here. So this is called your transitive functional dependency. Okay, so one column is indirectly dependent upon the column here in this case. So this is also it's not advisable to put it in this way in a table. Okay, so how to avoid this? Suppose this is the data, how we'll avoid to make it in a simpler way? Let's see that. So this is the way. So what I will do here is that I will create two tables here. First table is called the employee table, which will hold the employee ID, their name and their zip. And second table I will create, which is the uniqueness of the zip and city. That's it. And these two table will be joining with each other based on the zip. So that what will happen if somebody city is changing the zip or something like that, right? So I just need to change on the zip table only. So there will be no changes on the employee table at least, or the zip is not depending upon the employee now. The shifting of the two tables here. Make sense? Any questions here?
So, Samir,
See.
you mean to say, can you go to the,
Yeah, good.
okay, hold on. Yeah. So this
Hmm.
slide which I'm seeing now is not in third normal form, right?
Right.
So, and then the next slide, what you showed is following the conditions of third normal form. The two
Correct.
table,
Absolutely.
the split.
Yeah.
Yeah.
So this is
Oh,
the solution. This is the solution for the third normal form. Yeah.
okay, right. Yeah. Yeah. Thank you.
Yes. Okay. So any other further questions here? Okay. So this slide I will share it across you guys so that you can
Sir, I have a
go through that.
question.
Go ahead.
The first normal form and second and third, why every time the ID are going to change?
ID gonna change. No, this is a different example. I'm saying this is not a real data. Don't go with the data. I'm saying this is a set of data. If I want to
Okay.
put in a first normal form, this is the solution. If this is the data, this is on a second normal form, and this is the data, it is on a third normal form. This is not continuation of the example. I'm saying that this is the table, how to simplify it in third normal form. And this is the table, how to make it as a second normal form. That's it. Just give an example.
Okay.
Okay. So, and the last one is here. So, in case of fourth normal form, right? So, the first of all, it should be like first, second, third. It should follow everything. First, second, third, everything. Now, in this case, the fourth one. First of all, the first point has no multi-valued dependency. The third point is for dependency A to B, single value, all these things. Now let's try to understand here. I have a student ID here. I have a course and a hobby. Okay. Here, course and hobby, right? The hobbies are two independent entity. Hence, there's no relation between these two. Okay. Because I don't know if these two don't have any relationship. If you see these two columns, computer dancing, math singing, chemistry dancing, biology cricket, physics hockey. What is the relation between these two? Nothing, right? This is only for the student one, the course and their hobby. So if these two columns are not related to each other at all, why we will keep it in a single table? Not make any sense to me because one table should contain the student information only. Okay, like which course he enrolled, what he's studying, what are the subjects he's taking, and all. But these are all hobbies or extracurriculars. Like this is not exactly the I am more supposed to get it into my student information. Rather that it should be a separate table where I will store all the extra things for a student, right? So I should not keep it inside my student table only. So in this case, still these two columns are not like partial or the fully dependency on that one. So I'll just split it across the data, right? So now what is the solution for this? This is the solution. So I should have a data on two tables. One is the student course table, which will keep it all the information about the student only and related to the course. And the second one could be any extra table, which is called the student hobby table, where I will keep it the student hobbies and all. Okay. So this is one more example of a fourth normal form. Now, if you see all the normal form, right? So whenever you go to a real time, right, and whatever your data is where you are seeing that, right? It is following each and every rule, and finally, whatever the data you are fetching from the table, it is following all the rules, and finally, the data is getting inserted to a table. Okay, so now question would be whether this is our work. I said no. Okay, because we are not the database architect, right? And we are not starting up any project here. Okay, so when we are going to the company. So yes, once you be onto a senior level position like solution architect and all these things, that time these are the things will come into picture. But if you ask me why I teach you all these things, yes, it is required to understand. right? It is just for our understanding that the data should be in this way. Okay, that's it. That's it. This one, and this is the end of the slide, and this is the fourth normal form. Any further questions here? I'm just pausing for a second. I'll ask if you have any questions. Just let me know. No questions? Okay, we are good now. So this is about your the normalization. Then what is denormalization? So it is something like whatever you discussed on the normalizations, right? Different rules, and finally, this is the rule you should follow when you are inserting the data into the table. So the reverse of the normalization, we should not follow anything, and that is called your denormalization. And most of the, I say this is a very important, most of the BI projects or business intelligence product, which is related to Tableau Power BI, follows denormalization. Why? I'll tell you later on the class. Okay. And where you will do the normalization? In case of transactional data. Transactional data follows normalization. Transactional data means banking system. Okay. Take an example of a banking system. So you are doing an online transaction, immediately it is reflecting to your system, right? Suppose you done a transaction, immediately that deduction amount or the refund amount, anything you are seeing, that it is immediately reflecting to your account. So this is an example of a transactional system. Like you do a transaction and immediately the effect is there for you. So that is called a transaction system. Okay. All right. Any questions? Now we'll discuss about another properties of the database, which is called your acid properties. Acid properties is not like the chemical acids and all. Okay. So let's discuss about what is called a acid properties of a database. Okay. These two are very important for an interview perspective. Okay. The normalization and the denormalization, acid properties, then what is data warehouse, all these things we'll discuss first. Okay. Now take an example of acid properties. Let's start. So this is called a acid. Okay. What is acid? Acid means the transaction or the sequence of a transaction, that is called the acid. Okay. So you are just take an example of a ATM transaction here. So you are first of all you are entering to the ATM, then you are putting your what do you call, you are putting your card inside the ATM machine, then you are keeping your PIN number or whatever maybe you are entering, then you are putting the amount which you want to withdraw, then finally based on that it is getting withdrawn, then finally you will get a receipt saying that these are the things, and that's it, exit. So this is a sequence of transaction, right? So first of all you need to enter your card, then enter your PIN, then enter your amount, and all these things. So there is a sequence, and let's say one of the sequence is not working, then what will happen? the transaction will be failed, right? Suppose you are putting a wrong pin, so your transaction will be not done. Suppose let's take after you entering the amount, uh, the amount is deducted, but the cash machine unable to give you the amount which you are looking at. So in a uh, sequence of process, one process is not working. So that is the acid properties. So acid properties is the sequence of the data which you are planning to the database, and one, if it is not working, the whole system is getting gone. In the sense it is done. So this is called your acid or the acid properties. Okay, got the point?
Yes.
Okay. Now let's see what is acid exactly. Acid is, as I told you, is not the chemical acid, right? Which you were testing on the chemistry lab and all. So acid is stand for this three. So acid is A for atomicity, C for consistency, I for isolation, and D for durability. Okay. So this is the definition I kept it, but we'll discuss. I just don't want to read this, like what is atomicity, what is consistency, what is isolation, and what is durability. But acid stands for this. Okay. A for acid, C for consistency, I for isolation, and D for durability. Okay. These are the properties of the sequence. All right. So let's not focus on the definition. You can later go with this definition only, but let me jump into the atomicity first. What is atomicity here? Let's take an example of atomicity here. So here, atomicity means ensure that all operation in the work units completed successfully. That is called your atomicity. So whatever the transaction you are doing it, the process, the sequence, all the sequence should be processed successfully. That is called your atomicity, the property. Take an example. So we have a customer A. He is transferring the amount to the customer B. Okay. So first transaction he did it. So balance is 800. Is transferring customer to 200, and this transaction got successful. So what is the balance to be 600? Okay. And whereas the customer B is having 500 and he got 200 amount got credited from the customer A, so the balance is 700. So this is a process they are following, like they are making a transaction, and this is a example of a atomicity. Okay, each transaction is following the sequence, and finally the transaction is getting successful. But the problem is the second one. This is not an example of a atomicity. So whenever customer is transacting the data or he is doing a transaction to the customer B and it got failed somehow, wherever the whatever the maybe the problem here there in the latency in the network or in the banking system, whatever could be the reason here, but the transaction got failed, right? So that's the problem in this one. This is not an example of a atomicity, but this is an example of atomicity. So the atomicity should be the priority in a SQL statement. So the sequence or the transaction or the flows, whatever you are doing on the SQL, right? It should follow or it should be successful. Okay, make sense?
Sir,
Mhm.
atomicity is like the transaction is making successfully. It's atomicity, but whenever it becomes like the transfer transaction
Yeah,
is failed, it's not
yeah,
atomicity.
correct.
Yes?
Absolutely. Yes, yes, absolutely.
Yeah. Like whenever we want to we are using our card, debit card in ATM. So
Hmm.
whenever we are transferring cash or in our card, so or we want the withdraw
Hmm.
from our
Right,
card.
right,
So we are writing amount. So whenever we take it out, this one, the transaction is successfully, it's atomicity, right?
correct, correct. Absolutely correct.
Yeah. Okay.
Absolutely.
Okay.
Okay. So the first acid property is called the atomicity. Then we'll go to the C, which is called the consistency. What is consistency here is that ensure the database properties changes state upon successful committed transaction. So what does it mean? Suppose you have done the transaction. Okay, sometimes what happen, if you remember, sometimes you are doing an online transaction on the bank system and you transact the amount. Okay, you done a transaction and that amount got deducted from your account. Okay, but sometimes what happened, the receiver is not yet received. It is successful, but it's not the receiver is the whom you are transferring the amount. Still, he is saying that I'm not yet received. Okay, it will check. I don't know, maybe some network issue or whatever could be the reason here, but he is not yet received. Okay, and uh, say that it is somehow that it is take let's say 2-3 hours to reflect it. Let's take an example. Second, take an example of that you done a transaction and it got failed. Okay, it got failed and the amount got deducted from your account. Okay, and it's just supposed to be get refunded within the 24 hours, right, or 48 hours, whatever the bank policy will be there. It should be available to your account. If that is not happening, right, that is the problem of the consistency. So I am doing a transaction, the receiver is not receiving the amount. If the transaction is getting failed, I'm not getting my refund within the time, right? That part is called your consistency. First is the atomicity, second one is the consistency. Make sense here? Two properties?
No, sir, I didn't understand this one.
Okay. Okay. So let's take an example here. Just let me put it in this. So atomicity means what? The process, right? All the process. All the process should be complete. Should be complete. Okay, so let's take an example of your the transaction, ATM transaction or your online transaction. So you are doing entering your account number, the receiver account number, the amount, then you are pressing the send. So you are following a process, right? First process, second process, third process, fourth process, and each and every process, if it is completed, then only your transaction is getting completed. You are okay with this? Hello?
Yes.
Yeah, now I guess that is clear, right? The first process.
Yeah. Yeah.
Now comes to the consistency. What is consistency here is that you followed all the process, okay, and you did a successful transaction. Still, what happened is, whom you are sending the amount, he is saying that he not yet received. It should be delivered within seconds only, because nowadays the transactions are very fast, right? It should get delivered to the person within a seconds, right? He's saying that I not yet received. First, second, let's take you followed all the process and still the transaction is getting failed. Okay, and the amount is got deducted from your account. So the problem is the transaction failed and your amount got deducted. Now you should get refund that amount, right? So there should be a rule within the 24-hour or 48-hour, the amount should be refunded to my account. If that is not happening, so in the database we are not performing a consistency. So there is no consistency rule in my database. That is called a consistency. Make sense now?
Yes.
Okay,
Thank you.
no problem. So we have discussed about the consistency. Okay, so this is about the consistency. Now the next property, I property, this is called the isolation. What is isolation here? Enable transactions to operate independently and transparent to each other. Okay, what does it mean? In a banking system, right? You are not the one person who is doing the transaction, right? So many the customers across the world, they are doing their transaction. So in this case, take an example of customer A and customer A is transferring amount to the customer B, and the same customer is doing a transaction to the customer C. Okay, so same person is doing transfer to the amount customer B, and same customer is doing a transfer to the customer C. So there are two customers, both are different. Okay, but the rule says the isolation is that customer B should not know what transaction customer A is doing to customer C, and same for the customer C also. He should not know what is the amount or what is the transaction the customer A is doing to the customer B. So both should be isolated to each other. Only the person who is doing the transaction, he should only know that yes, the customer, I'm doing a transaction to this person X amount, and this amount, this person Y amount. This is called your isolation. Make sense here?
Yes.
Any question?
Yes.
Yeah. Okay. So atomicity, consistency, isolation. Okay. The last property, which is called the durability. Durability is something like ensure that the system is up and running. In the sense, whatever, let's take your, sometimes you saw that, right? The Imagine or your WhatsApp or your, if when your, whatever the network system you are using it, let's say it's down. So it is affecting millions of people across the world or the billions of people across the world, right? So the durability feature is something like we should have a proper mechanism for the system failure. Okay, and you should have properly maintained the system that it should not fail in so many. Suppose this example. Let's take an example of a bank system. Suppose you are into a XYZ bank and you observe that their system is very slow and their transaction systems are very bad. Like whenever you are doing a transaction, out of the 10 transactions, 7 transactions is always getting failed. Okay, so that is a bad system only because they don't have a proper mechanism to simplify the durability process, right? And they don't have any proper mechanism for the system failure also. So that is also needs to be take care while designing of the database. So this is about your ACID property. ACID, ACID. Okay. A for atomicity, where all the processes should be run smoothly. C is the consistency, that after the each and every process I followed, I should see the transaction what I'm supposed to. Okay. Isolation means, isolation, I understand that both the, let's take I'm transferring an amount to the both the customers. So those receiver customers should not know what transaction I am doing to both of them. Okay. So that is called isolation. And the last property is called your durability, which is talking about your system failures. The system should be up and running always in this case. Okay. Make sense? Any questions? Let me just sip a little bit of water. Okay. Any questions further? No, you are good.
Good. I understand
Okay.
it.
Okay. That's great. So this is about your consistency and all these things. Okay. Now this is about your this one. Now let's comes to the very important topic, which is called your data warehouse. Sometimes, sorry, there is a difference between database and a data warehouse. Okay, what is a database and what is a data warehouse? Take an example of this. Okay, so take an example of a bank system here. Okay, in a bank, we are maintaining a database. Let's take we are maintaining a database where we are keeping all customer information, all information, I would say, all information. So whenever you are logged into uh, your net banking site and all, right? So based on your customer ID login, you will get all the details, right? So your balance, your whatever, your credit card information, or if you are investing in something like any kind of mutual funds or anything, all the information it is showing it. Okay, everything is showing. Now take an example of a bank system. I want my bank statement for last 4 years. Okay, last 4 years. I don't know about the your like US and all, but in India I'm talking about. Like suppose I am logged into my internet banking and I want the bank statement of mine for the last 4 years. Is it possible to get it or last 5 years? Is it possible to download from your net banking? I don't know about you guys. How it is? It is possible on your system? Hello? Yes, please answer me on this
Yeah,
one.
I think 2 to 3 years maybe we can get, but
Max.
maybe
Max.
not 5 years.
Correct. Correct. So it is like max we can take 2 years. Let's take an example, 2 years. Okay. If it is beyond that, we need to visit the bank and get the data. Right? So it means that what does it means that what about the data you are seeing that they are maintaining a database which will hold only 2 years of data, not beyond that. And all the history, like 5 years, 6 years, 7 years of data, they are maintaining in another database. Historical data for more than 2 years. They are maintaining in a separate database, which when you visit your bank, then only you will get it. Okay. So the first is whatever you are storing daily transaction data and almost up to max 1 year or 2 years data, that is called your database. Okay, and where you are maintaining all the historical data, it could be more than 10 years, it could be more than 20 years, depends upon your the bank relationship you have. So that is called your data warehouse. First thing, first thing is. So data warehouse and database are same. It's a database only, but the way we are storing the data that differs. In a normal transaction database, right, we always store the data up to certain years. That's it. We will not clump the data because daily we are accessing the data. Okay. Whereas the data warehouse, warehouse means something like we are keeping all the information. What is warehouse? Like suppose let's say car warehouse. So we are keeping all the cars. It is like a dump. Okay, we are dumping everything, and whenever it is required, we'll just get that information from there. Whereas the normal database or the transactional database will keep certain amount of information only, so that it will be easier for that information, or the customer will get the required information in a faster way in the database. Okay, so this is the first information. All right. Any questions here?
I have a quick question, Samir. Like,
Go ahead.
so as you said, the data warehouse is like a dump house. So what's the difference between data lake and data warehouse?
Okay.
Both the
Yeah. Okay. That I'll come to that. Just give me
okay.
a second. Yeah. So this is the database and this is the data warehouse. This point is clear, guys? Or any questions here?
Yes, it's clear. Yeah.
Okay. And the one more difference here is that when this database, we are talking about a banking system, right? It is getting inserting or updating frequently, in the sense, whatever you did the transaction, it will be automatically updated to the database. Whereas in the data warehouse, suppose let's take an example, you are a customer and you did, uh, let's take 4 transactions today. Okay, 4 transactions today. So once you did the transaction, it will be auto update into your database immediately. Okay, but into data warehouse or the DWH, this is the small set of thing. Okay, DWH called the data warehouse. Okay, into the data DWH, what will happen at the end of the day? At the end of the day, this transaction will be moved to the warehouse. Why? Because we want to keep the history of your all the transaction on a day. So let's the day finish first. So let's wait for the banking hours needs to be finished or the day to be finished. And based on, okay, you did a 4 transaction today, let's move this transaction to the data warehouse. So this is the way it should be moved based on time or based on certain interval of time, it should move to the data warehouse. Okay, all right. And normal database, and here and the two terminology will come into picture. So which I'm talking about the database, right? Where all the transaction, whatever you did the transaction, and it is getting captured into the database directly. Those kind of database is called the OLTP database, or it is called online transactional data, online transactional processing. Okay, and the data warehouse where you are keeping all the history information of a customer, where you are keeping all the data, that kind of database is called the OLAP, which is nothing but your online analytical process or analytics process. Okay, so OLTP transaction
Sir,
system.
with data warehouse, like it's also online and like analytics and online, both of them, right?
Yeah, and this database is will be used for the analytics only, where you will use the Power BI or Tableau or any kind of reporting system, right? We want to analyze data because for the analysis, I need more data, more into history data along with the transaction data. So the transaction data is something like just to get the information. That's it. The customer, I want to see that, okay, last 6 months, what I did. Okay, these are the things I did. But if I need last 5 year data of a company and I want to analyze the profit on that information, right? So I should have a OLAP system where that is called a data warehouse.
Mm-hmm.
Good. Got any questions? Yes.
I'm good. Thank you.
Okay. So now somebody asked the question is called the what is data lake? So data lake is something like, if I simplify this is, okay, so it is like a, what do you call it? Not exactly got the definition for it, but universal data, I can say, or the centralized data. Centralized in the sense, I'll take an example. Centralized data ecosystem. Okay. So take an example of a company here. Let me open the Excel. This will be easy to explain. Okay. So let's say this is my XYZ company. So what I have multiple departments I have in my company. Okay. I have a sales, I have a HR, then I have a HR, then I have a finance, then IT. Okay. Then I have a purchase, all these things. I have departments. Okay. So nowadays what happened? Previously what was happening is, so they said sales data. Okay. I am keeping in database one. Okay. Which is on anything, depends upon the choice also. Okay. So I am storing inside my SQL Server. HR database, it is storing inside another DB2, which is also on the SQL Server. Okay. Finance data, let's take a DB3, it is going to Oracle. Okay. IT is DB4, again it is storing in the SQL Server. Okay. Purchase is DB5 database, which is on the DB2. This is the way it was supposed to be previously, earlier. What now company is saying that, okay, these are all scattered data. So let's take an example. Suppose I am into a sales data, sales information, and I want to analyze some HR data also. Some in my current report or something, I need the HR data. What will happen? I want to request these people to get me access to this DB2, the database 2, to get some HR information, right? So, and the two database I need to connect, in the sense one is DB1, one is DB2. So there should be a database to database link should be there. Okay. And that sometimes it is like very slow in performance. So what now how it works, right? Let's take an example of a centralized ecosystem. So this is my only one database, only database. Okay. Let's take this an example of a centralized ecosystem, how it works. It is, let's take an example of a Snowflake. Okay. So Snowflake is the database where it will be centralized. So inside the Snowflake only, what I will store? I will store my sales data, my HR data, my finance data, okay, and my IT data and my purchase data in a single database only, with different schemas and all. Okay. Then this is the access I need to the Snowflake and based on whatever I needed. But instead of going to the different database, I will go in a single database for different schemas here. So this is called your data lake. So data lake is something like the combination of all the information of the data, which is called the data lake. Okay, make sense?
Yes.
Okay. Any further questions? Okay.
I'm good.
Okay. And coming back to the like installation, guys, go to this SQL developer for the next class. SQL, just search for this SQL server. Okay, SQL server download on the Google, and take this one. Okay, I'm pinging you the URL also. It is, let me ping. Chart is there, right? Getting the chart. Yeah, this is the link. You need to go there and don't go download all this thing. Download this part, the developer one. Okay, download now. So once you download now, it will be an exe file. It will be get downloaded. Okay. You just download it, don't install it, and tomorrow, like all the exe, just download the exe and make it ready only. Don't install it. And somebody tomorrow just share your screen, then I will guide you there, like how to install the SQL developer. Okay, make sense?
Sure.
Okay, it's a very simple download only. Or somebody wants to do it right away, I'm okay. I have a 10 minutes window for this if you have time. Somebody wants to do it now?
Yeah, okay, I'll ready to do.
Yeah, Rajni, please go ahead and share your screen so that everybody knows that how to do that. Yeah, I'm stopping my sharing. You please share it. You have the rights to share. Let me
No,
check.
I don't have any rights. Actually, I'm
Okay.
unable to share my screen.
Yeah, just I'm doing. Now see, I think you should have now. Yeah, go
Yeah,
ahead
I
and
got it.
yeah, and the link I pasted in the chat, right? Just open that, or you can put SQL Server download something. No, SQL Developer download put, not developer edition anything. Don't go down, go down. Yeah, that link only. Yes. The certified link. I'm not able to hear you, Rajni. You're on mute.
Oh, I'm sorry. Okay.
Yeah. So
So,
you click on that link. No, yeah,
the
that
my
Microsoft.
okay.
Yeah, yeah. Click on that. Not this
This
one.
one?
Wiki, not wiki. Not wiki. Pavan,
Okay.
that it is there, right? The SQL
This one.
Server download. Yeah,
Microsoft.
correct.
Okay.
Fine. Go down.
Mm-hmm.
Yeah, the developer download now. Yeah, click on
Yes.
it. It is getting downloaded on your down. It's already exe. Go to the folder where it got downloaded. Don't install from here. Don't click, don't click,
Okay.
don't click.
Okay.
Go to the folder where it got downloaded.
Okay. Where it got
I'm sorry to interrupt you guys. I'm actually Rajni's screen is not visible.
Is
I'm
it?
not. Yeah, for me it's not.
What
Is
about you,
everyone?
other guys? Everyone just confirm?
I could see.
Oh, you could see.
Also see. Yeah, I can also see.
Okay.
Okay,
Then,
might be it's my.
yeah. So, yeah, just maybe there's some issue. Rajni, go to the folder where you got downloaded. Go to your folder, downloads. Download folder will be there on your Explorer,
in my
right?
lab. Yeah.
Yeah, yeah.
One.
There. Go there. Not from here, the folder.
This
There
one
is a,
you said, right?
there is a, how you are going to a C drive, D drive on your system. Just go there.
One. Okay. Uh, uh, this one you said?
No, close this, please. Rajni,
I'm
don't faster close that. I'm saying yes to it. Yes.
okay.
I'm saying how you are going to your C drive or D drive. How you are going to your folder on your system.
I mean, I'm sorry, I didn't. I didn't get you.
Suppose you
Where?
want to go to a file in your system. You want to open it. Where you will going?
Can I help you, Rajni? Can I help?
Yeah, sure, please.
Yeah,
Thank you.
come down to the taskbar. You can see the yellow floppy disk.
Correct.
Okay.
Correct.
Oh,
There.
Yeah,
okay.
click that.
Click
Yeah,
that. Click
yeah,
that and go to the downloads folder.
yeah. Left side,
There will be left side downloads will be there.
desktop,
Okay.
downloads, documents. You have, see?
Yeah, sure. Thank you.
No problem.
No, no problem.
Yeah, this
I'll
one,
And
go
right?
and see, sir.
yeah, yeah, yeah. Right click on that.
Mm-hmm.
Right click. Yeah. Run as administrator. Second option.
Okay.
And it will ask you to yes and no. Put yes. That screen will be not visible to others. Okay, guys.
Oh,
Just make sure.
okay.
Did you press yes? Yeah. Okay. If
Yes.
you are and select the basic. This basic is fine for us. Select the
Oh,
basic.
okay.
Agree. Accept.
Okay. Shall I do
Take the take.
install?
Nothing needs to do. Install. Yeah. No need to
Okay.
change, guys. The path, whatever it is showing it here. Okay. Just install it. Okay. It will not take much time here. It will take very less time. And don't go very fast, Rajni. Okay. Just wait for some time if anything pops up after this. Okay.
Yeah, sure.
Yeah. Wait. And sorry, guys, I'm just keeping waiting for you all, but this is important because if you're not stuck in the installation, let's seeing this. Okay.
Sir, I can't download this with mobile.
Sorry,
Yeah.
what is that question?
I can't download this with my mobile. I can't
Mobile.
find the server.
But mobile, why you will download it mobile? Because this is required a laptop, right?
Yeah,
We will not able to do anything on mobile.
I have to on with laptop.
Yep.
Okay, but today I'm on with on mobile.
It's fine, no problem. You can take your time, and after the class also you can download, right?
Okay.
So for tomorrow's class, like the
Mhm.
SQL Server, I cannot download, and I'm not ready with my laptop. So
Mm-hmm.
can I use MySQL? Like I have a Mac.
Yep. Yeah, sure. You can go ahead. There will be little bit syntax difference will be there, Bali. But
Mhm.
if you have any error on this, any kind of normal first level, there will be no changes. Okay.
Okay.
And if anything changes, just you need to just Google it up, saying that okay, this is the syntax in SQL Server. What is in MySQL? So that's it.
Mhm.
Nothing
Mhm.
else.
When we will be using start learning Power BI?
After this done, like makes 1 week to this one. Yeah.
Yeah. Okay. Thank you.
It's taking a little bit time, I guess. It's progressing. Okay, wait. Here, after the done, there is a button called install SSMS is there, right? Near to
Yes.
customize, click
Mm-hmm.
on that. Yeah, it is going to a download folder. Just minimize this and go to browser.
Okay. Mm-hmm.
Yeah, go a little bit down and download the SMSs. There is a free download SQL Server Management Studio. Yeah, that click on.
Yeah.
Thus, this is the integration or the tool where you will write your queries. Okay, this is called the SSMS because now your database is installed on your system. Okay, only thing is we need a interface where you need to write your code, right? So that is called your SSMS, SQL Server Management Studio. Okay, now after the installation completed, again we need to go to the download folder only, Rajni. How you went the last time, okay? Yeah,
Mm-hmm.
go there.
Mm-hmm.
Yeah,
This one again.
no, next second one. That one you
Oh,
already done. Yeah, right click and same.
Yeah. Same run and administrator.
Yep, yep.
Should I go S for this?
Yep. Yes, yes.
Yeah.
Rest.
Restart.
Yeah, it will take restart and do one thing. It will take a restart, and that
Mm-hmm.
installation is very simple. It is also next, next, next only. Okay, don't do
Okay.
that. I'm
Okay.
saying
Okay.
just after the rebooting of system, that
Mm-hmm.
SSMS it will prompt you to install again. So it will
Okay.
just next, next, next only, and we are
Okay.
done. Okay, okay,
Sure. Thank you.
sure. Yeah, that's it. Okay, then we are done for the today, and let's meet tomorrow in the same time.